First of all, very good evening to everybody here and good morning to you, sir. So, I welcome you all here to the second webinar of the TechPhilia series by the Ian Ham Club. And this one is a very special webinar because we have asked sir, we have requested sir to give us a webinar in the morning. So, sir is Mr. Praveen Salitra. He's going to talk about cloud native engineering principles. And sir is the Director of Technology at Egen Solutions from Chicago in the USA. And sir has worked with a lot of startups and enterprises, and he has given solutions to a lot of problems. And he has used a lot of technologies that he has learned over his career to help people out with their technical problems. And Sir has trained more than 5,000 engineers on cloud native technologies. So I think it is a very amazing opportunity for all of us to listen to him. And once again, I welcome you, sir. We are really fortunate to have you with us. And without wasting any further time, let's directly start with the webinar. So I hand over to you, sir. I hope nobody is having any kind of technical issues. If you are having, then please mention. I hope audio and video, everything is clear. So yes, I think that's a green flag. We should start. Over to you, sir.
Yeah, thank you. Thank you, NIT Warangal, as well as all of the core member of this particular group. Just one confirmation, last confirmation probably. You can see my slide deck, right? The cloud native engineering principles.
Yes.
Okay, perfect. So hello, everyone. I'm really excited to share my learnings from the last 10 years of building cloud native platforms for startups, for enterprises, building teams. And then I'm squeezing all that understanding into the next an hour or less than an hour. So can someone mute? Please.
Okay. I request everybody else to please mute themselves. And if you have any questions in between, you can put in the chat box, please. Thank you.
Thank you. As you can see, if you try to squeeze that much of understanding in 1 hour, we will be staying on a very high level. But then in the Q&A, if anyone wants to go in and dive deeper into any one of these principles, I would be happy to jump in there as well. Okay. So the whole idea is to understand if you are building a platform or an app, or maybe you are trying to go for software engineering jobs and things like that, right? So what are these principles as a software engineer you have to be aware of? So let's get started from there. So first question is, what is a cloud native app? So if you look in the definition, I think somewhere from Deloitte, it is an app that is architected specifically to run in an elastic, distributed, and cost-effective nature required by the modern cloud providers that you have, right? And then for this example, I'm going to be talking about, or keeping in the mind, 3 public cloud providers that we have, AWS, Azure, and Google Cloud. At Egen, we have been using all 3 for a lot of our different customers. So we have understanding from a specific vantage point. So we'll go through there. So the 3 keywords here that you will see are elastic, distributed, and cost-effective nature, right? Elastic, because you may have heard, right? The cloud provider provides you infinite scale. Of course, there is a finite thing there, but you don't have to worry about it. As a customer of these providers, you don't care where your servers are. You just go put your credit card, and then you assume things are available to you, right? In order to scale. Now, there are some of the regions of these cloud providers where things may not be that much scalable, but still, you would want to go to the primary regions. So elastic, meaning you should be able to scale up and scale down depending on the load on the systems and things like that. You definitely want to make it automated, right? You don't want to spend time overnight in the night doing operation support work and then firefighting. So that is one. The other one is distributed. Now, actually, your platforms, if they get bigger, and then if you are working on a startup and then that gets more popular, right? You would want to have more microservices, more teams working together on this platform. So it has to have some sort of distributed platform architecture that you have to support. And then, of course, cost is going to be an important characteristic here for this kind of platform. So we'll talk about all these principles which are going to be staying on these 3 core pillars of elasticity, distributed nature, and then, of course, how we can make it cost effective. And the idea is to make all of this automated mostly. So you would ask, okay, why should I care about all this, right? So there are a few different things that probably you're thinking. So maybe you are a developer, or maybe you want to become a developer after graduating from your course, right? And you are focused on software engineering. You want to work with the companies or the platforms or things where you are using some cloud providers, right? So you want to understand what it takes to build and run these apps. Or maybe you are more focused on the infrastructure side, operation side. So you want to become an SRE or a DevOps personnel again in these modern companies. Or you and a couple of your friends have some killer idea and you want to bootstrap this startup, small startup. Right now, it may be you don't care about many of these principles at this point because you just want to get users to your app, your mobile app, your new idea. Maybe down the line when it scales and maybe it gets popular, right? At that point, you will come back to these principles and find out, you know what, looks like we have to refactor some of our code, some of our infrastructure because we want to scale. That is the case. And then when you are looking at all these three angles, definitely one of the cloud provider you are keeping in mind at this point. I don't think I have worked with any startup who wanted to go on-prem within the last at least 6 years or so. So definitely you are going to be open to one of these cloud providers, if not anything else. And then you may have heard some of the open source frameworks that are more popular these days, whether it's containerization, whether it's functions, whether it's Lambda, Terraform, maybe someone has heard distributed streaming platform like Kafka and things like that. So that's the whole idea about this particular session. I will walk through those kind of things. So who am I? I'm Praveen Salitra, a technical or team builder, or more importantly, I code still. And then I like to venture out into new technology stack, do the POCs, work with the startups, give them the ideas, suggest them a few things, work with the legacy enterprise companies as well to platform or to architect the platforms if they are moving from on-prem to the cloud. So a lot of expertise or at least experience I have within the last many years or so doing this kind of thing. So, and I get to do all those things while being director of technology at Egen. Egen is a Chicago-based architectural consulting company. We help startups and the legacy enterprises just to provide the cloud native architecture, help them to build data pipelines, data engineering platforms, and things like that. So as far as the portfolio is concerned for Egen, and that's an important thing to understand because how are we getting all this understanding, right, of this principle? So we have worked in industrial IoT when industrial IoT was something brand new category 6 years ago. So we have started working at that point with one of the largest OEM in the world of machines. So whether you talk about predictive maintenance, asset utilization, operator monitoring, and things like that. And here in this category, we are talking about a lot of data. The word big data, that doesn't come close. We are talking about petabyte scale of data, but then also coming at very, very fast speed. So distributed nature is required. Cloud is required, and we have dealt with it for the last 5 to 6 years. We have a few customers that we have been helping, especially in healthcare. Now, there is no such real-timeliness required there, but still, you can make it more event-driven. These days, we have been working closely with some of the global retail enterprises as well. And there, it's the same concept. What we have done is we brought in our concepts from industrial IoT, where you are getting machine data or playing with machine data, and roll those concepts into the other verticals as well, and then some other one-off app or platform and things like that. The whole or the core idea has always been event-driven architecture, microservices, serverless, and cloud-native frameworks. And all of this, of course, going to be running and have been running on one of the cloud providers that I mentioned before. So on the technology stack, we have almost around 10 major projects at this point that we have been helping. So we get to our teams, or my teams are working on different technical stack, depending whether we are working with a startup with a 3 to 4 member team. Usually we go with anything which is pure JavaScript stack. Definitely fan of TypeScript, and then other kind of whether it's React Native for the mobile apps, Angular, even backend APIs done using Node.js based frameworks. Traditionally, we have been Java or JVM engineering group. So, but then eventually we have moved on to Python and Golang as well. Where we shine are actually the last three, where for the last few years, because of our ability to architect platforms that deal with a lot of this fast-moving data, streaming data to be precise, we were the first one to utilize Kafka at that scale. We were the first one to utilize containers 5 years ago, and container orchestration as well at that point. So a lot of things we have made mistakes, and we learn from that. And these are the learnings that I'm going to be talking about today. So let's get an overview. Now, this particular concept or this engineering principles are nothing new. 5 years ago, we started with a concept or a few points from Heroku folks who wrote this 12-factor wrap principle. There are 12 distinct principles, and they go in detail and talk about those. Now, some of them are not relevant, but what we did actually, we started with these principles 5 to 6 years ago, and then we have expanded on top of it. We have extended, to be correct technical term here. And the other thing is, whenever I say app here, what I mean by that is it's a process, a long-running process, provision on the server side usually, whether those are your APIs, whether those are your batch services, whether those are your databases, some other kind of processes which are running on server sides. All of these principles will be applicable to those apps, but then few of them will also be applicable to your mobile apps, right? Or your web apps. And there is a difference between mobile apps and web apps versus the server-side processes, because the runtime is not under your control if you are talking about mobile apps. I mean, your users have installed the apps on their devices, right? So the runtime is not under your control for the mobile apps. Same thing goes for the web apps as well. These apps are running within the browsers of your users. So you can't control everything there. But these principles are mostly applicable to anything that you can control end-to-end, whether the code, the build, the deployment, the infrastructure, the runtime, the monitoring, everything. So most of these principles are going to be applicable there. So the whole idea is to make any app that you have suitable for deployment on your modern cloud providers. And the whole idea here is, since we are dealing with different technical stack, we wanted to bring up these principles which can be applied irrespective of the operating systems that you are using. Although we are a fan of Linux, but then on our dev machines, it's Mac. So we want to get very neutral with respect to the operating systems. Programming stack is different. At least we are using 3 major programming stacks on different projects, or maybe a couple of them in the same project. Different sort of databases, different cloud providers. So these principles cut across all of those differences. The other thing is, the whole idea here is we are not tied for these principles to be applicable to a single tool. You will see a lot of examples that I will provide where you will have some open source tools that we prefer mostly, but then there are cloud services as well, the managed cloud services that you would want to use. Maybe then as the last resort, you want to roll out your own. So that's kind of the thing. And the whole idea is you have heard about this, right? Oh, this works on my machine kind of a thing, mostly from the engineers. Or this works in the lower environment, but it's not working in prod. So what's the problem, right? There are many things that can go wrong. So the idea is how to handle this divergence between having these environments, different configurations. And then, of course, mostly suitable for the teams who have the mindsets of microservices, CI/CD, automation, and agile. Maybe when you start as a startup, you may have a very small team, core group, and you don't care about most of these principles, and that's okay. You want users to be brought into your apps first before thinking about scalability or high availability and disaster recovery and things like that. So that's okay. But at one point, if you get famous, or if your applications or your platform get famous, you will probably come back to this principle. So, and then again, just from purely engineering perspective or a software development perspective, if that's what the track you are keeping in mind for your next maybe 5 years or so, these are the principles. If you have an understanding of it, I will hire you right away if it was me. So definitely a lot of demand for this principle, engineers having these principles or understanding of these principles. So let's get started. What are these principles? So we have 16 individual principles that cut across 3 different major categories. Some of them are architectural considerations that you will do before starting, or maybe when you are refactoring your existing apps. The other ones are infrastructure related, things that if you are mostly focused on DevOps and SRE roles, you will actually talk about or think about those. And then still staying on the SRE role, but mostly operational things where your apps are already in prod, some of the users are using it, you want to improve the performance, you want to improve the auto scalability and things like that. So we'll go in detail with each one of the 16 principles. So don't worry about looking at right now and getting confused. What are these different 16 names here or titles? We'll go in detail with everything. So let's get started here. And then, of course, the whole idea is gone are the days these days, or things anymore, where if you develop an app or a platform, you have to constantly serve it, meaning think of it like a living organism, right? It needs constant attention. So gone are the days when a Windows operating system would launch in 95 or 2000 or XP, and you will not bother updating it for many, many years, or including MS Office, right? These days, everything is online. Even your Office now is Office 365, the MS Office I'm talking about. Your operating systems need constant updates. So everything is a living and breathing thing. So you have to keep in the mind that whatever greatest app or platform that you create once, you have to continuously architecting it and automating it and simplifying it. So these are the principles which will make that also easier. So let's start with the first one. Treat everything as code. Now you will be like, well, Praveen, we already write our code and put it into version control, right? Like maybe GitHub or Bitbucket or GitLab or things like that. So what is new here? So that's true. If you're already putting your code into the version control, perfect. But we have seen a tendency where the code base will go into the version control, but the infrastructure config, any other kind of configs, secrets, meaning passwords and things like that, migration scripts, other scripts to handle your servers and things like that, they were not put into version control for a long time. So this is a new pattern, which is called infrastructure as code, and I call it treat everything as code at this point at least. The whole idea is to avoid the tendency to do this live code changes directly on running instances, running servers, running applications, right? It's always gonna be disastrous if you go there and if by mistake you kill some processes, your users will be affected. So follow the concepts of you have one code base, one repository, and you can deploy it multiple times. So whether you have one application, let's say an API, you have the version control in one repository, let's say on GitHub, and then you build it first, you package it once, and then you keep on moving that to lower environment, let's say dev to QA to staging, and then to production and things like that. So most important from a developer's perspective actually here is to understand Git. I have not seen anyone using Subversion in the last 5 years or so, especially if you are starting fresh. So Git is something I would encourage you to look into. And then understand a specific thingy called Git Flow. It's a specific branching model in Git that we follow, and that has helped us even provide CI/CD kind of a thingy, where we went to the extent of delivering multiple releases to production in a single day. So gone are the days when you would be having 3-month release cycles, and at one night on a Friday night or so, you will sit with all the release managers and then release it together with a severe downtime. It doesn't happen anymore in the modern companies. So from, again, going back to Git, actually, from developer's perspective, you have to understand what are pull requests, merge, rebasing, commits, push, pull, fetch. These are some of the commands. If you go before joining any other project, I would suggest going into and looking into Git. And then again, not just for the code, but also for your infrastructure. So there are many things available outside if you want to get started on this. Git as a command line open source utility, you already have it, or you may be having on your machine. But then get started with any one of this Git provider as well, or whether it's GitHub, Bitbucket, both of them provide free repositories, and then GitLab. Sometimes some of the enterprises also use GitLab. Terraform is a specific thing which actually brought up this concept of putting your infrastructure in the version control in terms of the config, bunch of YAML files and then other sort of code bases for your infrastructure. So that's HashiCorp's Terraform project, or Terraform tool actually, that we have been using heavily. So from your perspective, at least focus on maybe, of course, the Git CLI, but then also pick one of this and understand what the flows of the pull request is. Merge, releases, tagging, rebasing, commit, those kind of things. When you are working as an individual, you probably will not worry about merge conflicts or rebases, but as soon as you are in a team, you will understand what I'm talking about there. The Git Flow, so it's a specific release model. When you combine this with a sprint or agile methodology, you can do wonders of putting system or processes in your deployments of your applications to the environments. So this is one example. Again, I'm looking at, I should change this name now. It's called main on GitHub. So you have a main branch on GitHub, and then you create another branch out of it. You do all the feature work there with your team members. And then once you are done committing your things, you actually commit it back to develop. Anytime any changes are merged to develop, all these blue dots, put in automation so that it promotes those changes directly to the lowest environment. Then you can cut over a release to the master environment and then take it forward to higher environments like QA, staging, production, and things like that. So it's a controlled process where the whole idea is you will limit number of issues or bugs, and then it will go through a proper cycle, and not like anyone jumping directly and deploying it to prod, right? You don't want to do that. You would see, well, production deployment is taking almost like 2 weeks from here to here. Well, we suggest this for the new teams to start from this approach and put some sort of manual gets before you deploy to prod, because you may not have all the automation in place. But once you are comfortable with the test automation of your code, then you can squeeze this timeline to even to the extent that you can deploy multiple times during the day without doing any sort of manual intervention there. So this is a perfect model. As an engineer, you should be aware of some pieces of this at least. So we took a lot of time on first principle because that's one of the important one. Second one is immutable infrastructure. Now, we are talking about the cloud providers here. And not your on-prem servers, not the hardware that you have bought, right? So stop loving your servers on the cloud providers. If you have ever created an instance on any of the cloud provider, I mean, it's just piece of line item on your billing. And then it's just providing some ephemeral CPU and memory to you, right? You can always kill it and bring a new one. You don't have to stick to that server forever. So that's the whole idea of immutable infrastructure. It does not work on on-prem concepts. It only works on when you are working with a cloud provider. So what's this? The whole idea is build new servers whenever you want. Have some common images. Instead of modifying the existing servers and doing patching and security patches and things like that, don't worry about that. Directly just bring up new environment, new servers, new services, and then switch over your traffic from the old cluster to the new cluster. You shouldn't be worried about these days about operating system patching, security patching, any kind of traditional sysadmin jobs anymore. And then, of course, remove the issues where you have configuration drift, where maybe humans or your DevOps team or sysadmins, they did some in-place upgrades into that server, but you lost the track of what was done. So yeah, you can get rid of all those issues and you can just depend on this idea. The whole concept here is you have to have your infrastructure config into version control. Otherwise, you can't do this because you don't want to take down your environment for a minute in some cases, or maybe an hour in some cases. So of course, that's an important thing. It will force you, if you want to follow this concept, it will force you to put your infrastructure config into Git or one of the Git provider. And then, of course, build automation on top of it. And not just for the infrastructure, but use it for everything that you do, especially with cloud networking, cloud security, both in terms of network as well as access security, backups, databases, apps, scaling, auto scaling. All those can be configured using some sort of configuration mechanism. We'll talk about that. But yeah, that's the whole idea. You can put all of them into version control. You don't have to go and do it manually by SSHing to those servers. So Terraform is one of the most popular tool, which can handle for AWS, which can handle for Azure, which can handle for Google Cloud as well. But if you are talking about a specific cloud provider, AWS has pretty good service called AWS CloudFormation. Azure has something called Azure Resource Manager. Google also has a resource manager if you want to be specific to the cloud provider. But then if you want to be open to anything else, as an engineer, I would keep Terraform in my mind. Next, which is more on the architectural side, and it's called microservices, specifically stateless microservices. So what are we talking about here? Now, when you start any new startup, right, as I said again and again, your idea is to get users to your apps. You don't care about scalability at that point, and that's okay, because your entire future of that product is dependent whether your users can get to that product or not, right? So, but when the time comes when you are doing refactoring, or if you want to start from scratch with the concept of microservices, you want to have some modules which are loosely coupled, but they communicate over a well-defined contract, which is versions, whether it's APIs, RESTful APIs, whether using some sort of queuing mechanism, message queues, and things like that. So that's the whole idea. You may have multiple services. Let's say in an e-commerce platform, you can have authentication service separately running. You may have order orchestration service, or maybe you have payment service, right? And these can all be, and then other pieces as well. But this can be all different microservices running in the wild in your cluster. And then you can individually scale up and down. You can deploy them individually as well. And if your organization demands it, you can have smaller teams specifically tied to these services or a group of these services. And these smaller teams of engineers can take care of development, enhancements, deployment, operations, things like that. And we have done it. We actually go with that model of engineering, actually. So again, make sure you organize these capabilities based on business and not purely around database tables. So just to give an example, let's say you are in an e-commerce platform and you are creating, you're like, oh, let me go and adopt this microservice architecture. Don't go and break down your database, normalize into different tables, and then put a microservice in front of every table. So shouldn't it be like order line item service, or order service, or customer service, or product service, or inventory service, or payment service, or something else, right? Address service for that matter. In the case of Amazon, it may work out, but for your smaller group, you will start from a monolith and then break it down into services depending on the capabilities that you would want. You don't want to pay for latencies because you wanted to do distributed computing. Definitely, if you go with that route, these are highly maintainable, testable. Individual teams can put a lot of focus on what they are doing instead of worrying about hundreds of different services that you may have. And then again, depending on the load, you can easily scale them up, or more importantly, down as well to reduce cost. So now, depending on the framework, depending on the programming language that you are familiar with, you have options available. I have just listed 3 of them. If you are in the JVM world, Spring is pretty good framework to write microservices. If you are in Python world, Django and Flask are a couple of good options to understand what these microservices are. If you love JavaScript, right, Node.js, and there are a lot of frameworks, and we heavily use Node.js microservices as well on the backend. Now, coding is one part, right? But how to provide them the runtime, and that's where you will start hearing the words like containers. Docker is the most famous implementation. Kubernetes is when you have containers and you want to run them at scale, right? You want to have this services auto scale. You want to have high availability. If 2 of the services go down or 2 of the containers go down, you want to automatically bring them up, right? So that's why Kubernetes shines. So that's the concept of stateless microservices. Let's move on. The other thing is, not everything can be done on RESTful APIs in a modern ecosystem, right, or modern platform. The reason being, you will have to use some sort of async communication among services, right? Let's say, good example, you place an order, and then an email has to go to you, right, as an order confirmation. So when you place an order from a UI, you are talking to an order API, let's say. But the email, the UI doesn't have to wait until the confirmation, then saying, you know what, you have received the email. The email can go asynchronously behind the scene. And that's one small example of this. But then if you look broader, most of the modern platforms that you have, and even businesses, they are built around this concept of events. Your consumers, or customers, they want real-time and instant behavior from the systems, right? Now think about, let's say, placing an order on Uber or maybe Uber Eats or Swiggy or anything. You place an order, that's an event. The order is received by a restaurant, that's an event. They do prep, they do ready for delivery and things like that, right? Those are events. And when it's ready for delivery or ready for pickup, Uber or any other delivery company there or platform, they will then broadcast that event to any driver, any who is available to pick it up in a certain radius. That's also an event. An order, a driver will acknowledge that, okay, I want to pick it up. That's an event as well, right? So you get the point. So most of these things in the modern world are built around the concepts of events. And most of these things are happening asynchronously as well. So whether it's delivery economy, marketing, advertisements, especially in IoT, that's where our experience is coming from. 6 years ago, we were heavily dealing with these events coming from machines all over the world. We were handling somewhere around 3 billion events coming from these machines all in a single day. Whether it's news, social media, someone liked your post, you want to get notified, right? So things like that. So move away. The whole idea is whenever we are working with the enterprise and legacy companies, refactoring their platform, we are going with the idea of moving away from their scheduled bad jobs and then replacing them with streams wherever it makes sense. So for example, one of the customers that we are working on right now in the grocery retailer, they had an older 10, 20-year-old platform where everything runs on a batch mode, right? So the process waits for 6 hours, collects all the orders placed in 6 hours, and then start processing them. Instead of that, now we are going with the streaming approach, where as soon as the order is placed by the customer, we start processing it, right? So that the benefit is now we can provide some of the features like same-day delivery or 2-hour delivery. In the previous example, if you saw, if you wait for 6 hours, yeah, good luck. You are not going to be providing 2-hour delivery or same-day delivery, right? The best probably you can do is next-day delivery. That's not going to cut across your business requirements. Coming back technically here, your services are either producing messages or consuming messages from some queues, message queues. There are many examples available out there. This is also called a pub-sub architecture, where your publishers are maybe multiple individually loosely coupled services. Your consumers or subscribers are different, and they actually don't even know who the other side is most of the times. What they know is they have a queue, a system, a platform in the middle where publisher is producing the message and the subscriber is actually consuming it from there. One of the most open source and most popular platform is Kafka. If you have time, if you have understanding, read about it. But if you are on the cloud providers and if you want to use one of their managed service, you have a lot of options from all the 3 cloud providers there. Next one, which is the hot topic for the last couple of years, is serverless, right? Serverless, it does not mean you are not using servers at all. It's just that there are servers in serverless. It's just that those are not your headache. And when I say yours, meaning you, the engineer, you, the founder, you, the engineering lead or leaders of a company or a product. The headache is of the cloud providers for them to manage, right? So this is not a new concept. It's just the new marketing term, in my opinion. You had always these concepts of cloud hosted or cloud managed services, right? This is a new marketing term for that. Definitely, it got popular because of Lambda, AWS Lambda, where you can run a single function of your code independently and scale it to million Lambdas if you want, without paying much of the cost, right? So auto scalability and things like that. So that's serverless computing. That's how it got popular 3-4 years ago. But now there are more than just Lambdas or functions. There are many other things as well that you can utilize and that you can think of in terms of containers. Run containers without thinking about where are those running on your cluster. Run data pipelines or your build pipelines or your databases or your data lakes or your data warehouses without thinking how many CPUs and how much memory and how much disk you would need, right? The new consumption models are, if I get this many requests on my API, that's how I will be paying. That is what your functions are, right? Your Lambda, to be precise, on AWS, Google functions or Azure functions or things like that. There's already a lot of configuration available from the serverless services to scale up and down based on your usage. So you don't have to worry about, oh, I need a database, but I don't know, in order to support 100,000 users, how much CPU or memory should I need, right? You don't have to worry about it now. So there are some services which will allow you to tell, you know what, you need this many connections to the database, and they will scale up and down depending on the load. So you can give a range and not worry about CPU, memory, disk provisioning anymore. So pay-per-use model was always there. That was the beauty of cloud computing, right? But now that has been simplified, because so far you are still paying based on the CPU, based on the memory, based on the disk usage. And now things are more better suited for your consumption, where you're like, oh, I'm running my builds, and each build is on an average running for 3 minutes, and I have 50 builds on a day, so I should pay only for 150 minutes max, right? Instead of paying or running Jenkins forever throughout the day without even using it. So those are some of the beauties of serverless computing. Lambda functions, Google functions, those are the things that popularize this concept. But then, as I said, this concept is not limited to just the functions. You can apply it to many other examples that I have mentioned here. Cool. Now, this is one of the most overused concept that you may have seen, CI/CD, when you are working with an agile fashion, and you have the product and development process where the feedback loops are important, and you are releasing every 2 weeks or every week or probably every day. That's where you would need this concept, where you want to separate your different stages of your releases. So you want to separate the build, the testing, mostly automation testing, releases to environments, deployment to the environments, and things like that, right? So you have different stages. You are storing all this configuration into your version control, so that anytime you need it, you can run through the deployments in any environment. The tooling that you would need, again, will heavily depend on Git Flow. Some of the open source CI server like Jenkins is very popular. Look into it if you have not done it. SonarQube to check automation, to check your to check your code quality, static code quality, actually. And then if you don't like Jenkins, there are other cloud services available who can do the same job, whether it's AWS Code Build, DevOps, and Cloud Build. The beauty with this is these all three are serverless, so you don't pay for running this server forever. You only pay for the number of minutes you are using it. So let's say if you are building your Java app and creating a jar file out of it, probably it's going to be done in a couple of minutes, and you only pay for those 2 minutes. Pretty cheap rate there. Another thing from an engineering perspective or developer perspective, actually, is to move the configuration and the secrets outside your app or the code base of the app. So let's say you are writing a RESTful API. You need a database to connect to, right? So you have two options of putting the database URL and database username and database password. Either you put that database configuration inside the code and you hard code those things, or you actually provide those three things as environment variables to this particular app, right? So there is an important distinction here, because if you hard code the config and the secrets into the code base, then you cannot apply, or you cannot use the same code base or same package into different environments. So always think of not hard coding these things, right? Because these things may change based on the environment, based on the client, based on the infrastructure. In dev environment, your database URLs are separate. On your local, things are separate. On your staging, things are separate. Same thing goes in production as well. You don't want to hard code those things anywhere. And the better thing is to keep them outside. So some of the examples, whether your host names of some third-party services in your code base, passwords, API keys, private keys, certificates, long-lived tokens, and things like that. Do not hard code those things into your code base. Use environment variables or some injectable configs, new concepts. Pass them to your containers, pass them to your functions. Allow applications to run in multiple environments, because that's how this particular feature provides. So the whole idea, again, package your code base once, externalize the config and the secrets outside. So this guy doesn't know where the database is, where the code is, where the database is, what's the username, what's the password. You provide it at the runtime by utilizing some services like Vault from HashiCorp, which is a third party or a service. But then if you are on, again, cloud provider, you have many services to handle this kind of secrets and config available to you. Another thing is dependency. When you are developing an app, you will have two kinds of dependencies. The build time, which are third-party dependencies, modules, package, right, or jars that you would need for your app to be compiled. The other one are actually runtime. For example, for your API to run, probably it needs a database. Maybe if you are writing a Kafka consumer or producer, it needs availability of that Kafka topic or a brokers, right? So you can easily find out build time and build time dependencies. There is no issues. You already declare them using Maven, Gradle, PyPy, npm, things like that. The problem is actually the runtime dependencies because you don't specify them strictly, right? You specify them either using environment variables, some other sort of configs. So it will be harder to find out at the runtime what your apps depend on. So in order to have it, you can have some concept of health checks for your apps. Google this particular concept. The whole idea is you, before starting your app at the runtime, you tell if your third-party dependencies are satisfied, then only bring up this app. Otherwise, don't even bring this app up or running. Someone will notice and fix those dependencies. That's the whole idea. So for build time dependencies, I mean, depending on what programming stack you are in, you have a lot of options. For the runtime, there are some features available in containers and Kubernetes that can handle the concept of health checks for you. Again, very simple detachable backing services. So again, I think I already explained while talking about externalized config. Don't depend on the availability of external APIs, systems, databases, or hard code them actually into your code base. Don't hard code those things, right? What you should do is, or including the logging and metric selectors, treat them as pluggable resources that can be replaced, that can be changed, modified at any point. Because the whole thing you should be worried about is the contract between these two services, not what that exact host name of that service is, what exact port of that service is, the third service or the third party service. So that's the whole idea here. Use the concepts of externalized config, and that will take care of this particular principle. And as I talked about in the previous slide, configure health checks so that if one of these services are not available, don't bring up your service as well. That's the whole point. The next one, which is more infrastructure related or DevOps related, and many new things are happening in the community right now, are around service discovery, service mesh, load balancing, things like that. Now, again, this principle is not applicable or will not be applicable for your first ever app, unless you hit 10,000 or 100,000 users on first day or second day or things like that. So the whole idea here is you have containers, you have functions, you are using Lambda or Fargate or Kubernetes or anything. You are using containers in that fashion, and these containers can go up and down at any point. That means you cannot rely on the exact IP and the port of those services. So in order to do that, that's where the concept of service discovery comes into picture. There are services and systems available outside that can detect all the containers which are available right now. And then instead of relying on the IP, you can use a nicer hostname like the DNS and things like that. And they can try and match if the new container is coming up or the old one of the old one is going down. These particular systems can keep it updated always. That's the service discovery for you. And then depending on the load, when the load increases, you may want to scale your apps from one instance to maybe 100 instance, right? And if you do that, you need a load balancer sitting in front of it, which can do the round robin, distribute the traffic across all these instances. So that's the load balancer. And service mesh is a newer concept. I will not go into detail there, but just look for this if you are interested. The whole idea is there are many things that go around in distributed systems actually, from telemetry to observability to load balancing, access control between or among the services. So that's what service mesh can do. A lot of this tooling is available. We use almost all of them. Yeah. We use almost all of them depending on different projects. So Nginx is open source load balancer, which does many other things apart from load balancing. HAProxy is similar. Console is Stio, mostly for service discovery, service mesh. And then if you just want to stay with your cloud provider load balancers, you have options of from all of these three cloud providers as well. Another thing, is when you are working in a distributed platform, and if something goes wrong, you want to check the logs, right? So, but who will write to the logs? Of course, your apps should be writing to the logs. Now, in the traditional days, it would be the responsibility of the developers or the developers of the apps to figure out how and where to store the logs alongside the app and things like that. Today, or at least now in the cloud native world, the app developers should not be worried about, oh, where are my logs stored, or how should I recycle them, or how should I route them to some third-party service. No, you as a developer for your modern apps, you just write your logs to the std out and stdr, and then there should be some system in place which will take these logs from this and then put it into some centralized place with a nicer UI, so that you can go and debug when something goes wrong. So definitely implement that particular feature or a system for centralized logging, monitoring, alerting. Definitely don't go for SSHing to your servers, please. Understand how these logging systems are working. If you're using Splunk, if you're using Datadog, if you're using Elasticstack, don't treat log as a thing for checking consistencies, checking timeliness, ordering counts. Logs are only built, or logging systems are built mostly to debug issues and check what's going on, not for counting how many orders were placed on that day, right? That's not for the logging. For that, you may be needing some other sort of metric or metrics server. And there is a difference between logging and the metrics or monitoring part of it. So on that sort, you may want to use how much CPU my services are utilizing, how much disk, memory, and based on that, you can put some sort of automation alerts as well, so that your DevOps team can go and check that. And then you can have some other additional business-related metrics as well. Maybe you want to, or your business or your leadership wants to know every hour, tell me how many orders are getting placed on this platform, right? Either you go and check in the database, or you can put proper monitoring so that it can create reporting nicely and those kind of things. How many API requests are coming to your APIs, or how many messages your producers are publishing, things like that. So you can always write good kind of metrics. If you are into this kind of things, there are many open options available. Elasticstack is pretty good that we have been using with Kibana. Splunk is a service provided by Splunk. There are monitoring and dashboards as well called Grafana, and Prometheus works very well with Kubernetes-based things. And then again, if you are on the cloud provider and you just want to stick to some of those managed services, all the 3 cloud providers have one of that managed service that can provide logging, monitoring, alerting, things like that. Pretty quickly, auto scaling. Again, if you ever get popular, if you are writing a new app, or if you are in a company whose platform is used by many users, then you may want to think about auto scaling. Because based on the number of users hitting your systems, you will want to scale number of instances, or when there is no one using it, you want to bring it down, right, to save the cost. So you have both scale up as well as scale down for in this particular scenario. Auto scaling will come and help you there. If you depend on the manual scaling, then good luck. Your team may not want to risk, and they may just keep it running at the peak capacity every day, and you will definitely lose the cost. Reverse, if suddenly there is a load on the system, and if your manual or your DevOps team is not pretty fast in scaling the apps, it may take some time, and your new users will see errors or unavailable services on your systems, on your platforms. So that's another thing. Monitor the resource utilization of your apps, how much memory, CPU they are consuming on any time. Put dashboards, put metrics out there so that you can think about, you know what, these are my auto scaling rules. If you have non-prod environments like Dev, QA, probably scale them down over the weekend, assuming your engineers are not working over the weekends. Mine don't. Most of the serverless services, if you use them, they have auto scaling inbuilt. Lambda can scale to 1 million or whatever the higher limit that you put out there. Containers can scale easily if they are on Fargate and things like that. So pretty easy. And then of course, auto scaling is one specific group of services in AWS, but there are similar concepts available from all other cloud providers as well. And then Kubernetes provides a way to automatically scale number of pods, number of containers when the CPU or memory increases. So pretty interesting concepts there as well. Disaster recovery, again, I'm going to go very fast here. This is going to hit you when either you're working on a larger platform where you cannot lose any time or you cannot have any unavailability of your services. I mean, think of Uber being down for 2 hours on a day, right? On a specific day in a month. Yeah, good luck. I mean, they will have a lot of issues or nightmares with respect to public relations, right, or PR. So how do they do it? Well, the whole idea of cloud providers or cloud computing is, yeah, keep in mind, settle in your mind that things will go down. Systems will be going down, networking will have issues, all that kind of things are possible when you are working with the cloud provider. So if you settle with that mindset, the question is, how do you avoid it? Well, you can avoid it by keeping the mitigation and resolution of those issues very fast, right? So maybe you run two regions together. So you run one active, when something goes down here, you actually automatically port over or fail over to the passive region, and that becomes the active. And then your people are looking into what happened here, but your users are still directed to another region, right? Things like that. So you can think of all these things. The good thing is, if you are following everything so far, everything is a code principle, other pieces as well. You can easily spun up other clusters in other regions all over the world on AWS and Azure and Google Cloud very easily, comparatively easy. And then again, you can, if you want to have active regions, that's also fine. Maybe you want to have one set of your apps deployed in Mumbai, other in Northern Virginia. And depending on where the users are coming from, you may direct traffic into those regions, right? If something goes wrong with Mumbai, maybe the traffic will be a little delayed, but it can still go to Northern Virginia or somewhere else in the world. So a lot of those configurations are also available. Velero is some other one project that we use heavily, but that's specific to Kubernetes. Network and access security. So again, read something called OWASP top 10 vulnerabilities. That's something very important a developer should know. But then again, if you are working with the web applications, look into the firewalls. Pretty easy to configure them these days if you are thinking from cloud providers mindset. Put everything which is put all the non-internet facing services into VPCs or virtual private networks. Of course, in order to have this, you have to have good understanding of cloud networking. Maybe some other session, some other day I will do cloud networking one-on-one, things like that. But anyways, here, take care of your secrets, key rotations for your SSH keys, things like that. Do some sort of testing, not just for security or checking if your code is vulnerable, but also any other kind of DDoS testing and things like that. And run those checks as part of your build pipelines. Log down the routes, ports, and things like that. So a lot of options available, including for single sign-on. Use some capabilities available out there. One of the things that your engineers, your users will hate is having 10 different passwords to be used for 10 different services. So use something called a SSO or things like that. And there are options available outside, including a lot of things available on the cloud providers. All the cloud providers have some sort of IAM, Active Directory kind of concepts. So use them. A couple of more. So one other thing is, I mean, most of the times on the engineering teams, right? You would used to hear, or maybe now, oh, it works on my machine. Why it's not working in that environment? Or, oh, it works in QA, but it fails in production, right? So what can go wrong if it's the same exact package that you're running in different machines? Just the infrastructure can be different, right? And the other thing is maybe the data is different. So the whole idea here is, if you follow most of these principles that we have talked about so far, you will be able to keep your development, your staging, production environments, configuration as similar as possible. Because remember, all these configurations are sitting in your code base, right? Or version control. So not like a human or DevOps person forgot to apply it in QA, but applied in production. Things like that will not happen if you follow the concepts that we discussed before. But then you would still want your development, maybe your non-prod environments, to be smaller in size, just to save the cost, because not many users are using those things, right? Just the internal users. And then try to have all the services deployed and running in all the environments. The only difference should be just in the size and the capacity. Reduce the resource quota in the smaller environments just to save the cost. destroy or scale down your load environments during the nights or the weekends if you see no one is using them. So those are good concepts that you have. Cool. The last one, you have grown to a larger scale, and now you have to worry about the cost because cloud providers can be costly. Because of course they treat you saying pay per use, but then if you don't pay attention to the cost, then your credit card bill will be shooting to very high values, right, every month. So pay attention to it if your platform is famous or if you are responsible for this kind of thing in an organization. So pay for or focus or analyze your billing dashboards, set up appropriate alerts there if available. There are many options to reduce costs, and I have written an ebook that I will link you here, and that covers all 10 different ways to reduce the cloud costs, whether using reserved instances, spot instances, different kind of instances which are cheaper, auto scaling apps and infrastructure when no one is using them, or scaling them down. Using most of these managed services, so you don't have to have that many system admins or DevOps teams on your side, so you will save there. If you plan your regions or your infrastructure nicely, then you can avoid the data transfer charges because most of these cloud providers charge you to pulling out data from them. New services optimization constantly coming from this cloud providers, so focus on those, do the POCs, try it out, see if it makes sense. And then if you are a startup, there are a lot of credits available from these cloud providers. For example, AWS provides 100,000 credits worth of 100,000 US dollars for a startup which is qualified. So a lot of hefty discounts is available if you can qualify for those things. So we are at the 1 hour mark right now. So let's talk about the takeaways, because we are done with our 16 principles, core principles for the cloud native engineering. From a developer's perspective, you would be like, I'm a grad student right now. What should I focus on? Because I covered a lot of things there, right? There were many icons on the side. So of course, the first thing is to get better at programming, algorithms, data structures. Those are the concepts that you have to keep always improving, always getting better at. Apart from that, then at one level, start thinking about, once I'm in a team, how would my code work with someone else? And if all of us are writing in the same repository, understand Git Flow, look into some tutorials over that. Understand what is pull request or PRs, CI/CD pipelines, or Agile or Sprint or Scrum or things like that. Those are the processes that you should be aware of, right? When most of the times when the students get out of college or universities, and when you hear the words they are not industry ready, these are the things we are talking about. They know basics of programming and algorithms and data structures, but they fall short on some of these processes, because differences are there when you work alone versus when you work in a team of 10 engineers, right? Two of them are just QA, or three of them are, or one of them is just a product analyst. So another thing is microservices. Start looking towards them as well. Whether you are developing RESTful APIs in one of your favorite programming stack, you have a lot of options available these days. Look into how you can run these microservices in containerized fashion. So you have Docker Compose, Kubernetes. And again, if you see, I have not used a single proprietary programming stack. We love open source. So a lot of those things are what we use are open source as well. So you can always find the source code, learn from there as well. For the config, see what are environment variables, how you can provide secrets and secure them outside your applications without hard coding them. And then pick one of the cloud service, I would say. If you are starting, maybe there are a lot of certifications available at the associate level. AWS has many, Azure has it, Google Cloud has it. See if you want to go for those certifications, if you just want to get a taste of what the services are. Start with compute and storage services for the starters, and then go deeper into, maybe I want to focus on DevOps or networking or security kind of things. And then if you are want to go into data engineering, the thing that we love the most here at Egen, there are many open source frameworks which you will love actually. Completely new concepts. So whether it's Kafka, which has revolutionized how we handle streams or streaming data now. Spark, if you want to do a lot of batch processing, a very high load of it. Airflow, if you want to orchestrate different processes in a pipeline kind of a scenario, or in a graph kind of a scenario, I should say. data lakes. The concepts of databases has been evolving, right? Databases, RDBMS, NoSQL databases, data lakes, whether it's AWS S3 or Azure Data Lake Service or Google Cloud Storage, or data warehouses, Redshift, BigQuery, or even as popular as Snowflake, right? So those are the things. I would say start with somewhere there in the middle. Get yourself prepared with the industry readiness, as we call it. And then once you're there, I think happy to talk to you again. So that's pretty much it. What I